Good evening, everybody. My name is Kevin. Welcome back to the ESP32 product creation journey, where we are continuing to figure out the firmware for our ESP32 device. Specifically, this evening, we're going to be working on the provisioning. Earlier today, we played with the unified provisioning component in basically setting Wi-Fi credentials on our device from our cell phone using basically the out-of-box apps that Espressive has provided. And what we found earlier today is that BLE is massive. And after I got off that stream, I found that this is a very common complaint from other people developing apps for the ESP32 is that the BLE stack is gigantic. They have added Nimble. So the ESP32 gives you two options. You've got Blue Droid for BLE, which will handle BLE and Bluetooth Classic. So for those that maybe are new to Bluetooth, I'm not an expert, but one thing I do know, and I learned when I was at Microsoft and we were building some stuff for the Arduino and Windows IoT Core, was that there's Bluetooth, classic Bluetooth, BT, and then there's BLE, Bluetooth Low Energy. They are not the same at all. They share Bluetooth. That's simply from a marketing perspective. They are two very different things. And so it's not like a Bluetooth and BLE are like USB 2 and USB 3. It's not like that. They're completely different things, completely different animals. And so Blue Droid in the ESP ecosystem supports both. You can do a BLE and a Bluetooth stack. Nimble, NIM BLE, is just BLE as far as I'm aware, and is a more compact package component for Bluetooth. I'm sorry, BLE. Like, it's important to distinguish. When you say Bluetooth, you're normally referring to classic Bluetooth. BLE is Bluetooth Low Energy. So that's where we're at. And something that I found, I'll go through some of the things that I learned going through this process. So earlier, if you missed the stream earlier, we just took the unified provisioning code, removed the Wi-Fi soft config stuff, smart config, soft AP stuff, and left it to just BLE configuration. And it worked pretty sweet. Like, it was pretty slick with the built-in Espressive app, like getting credentials onto the device, very smooth. The problem is the executable is, the binary is huge, like almost a meg. And so, but one thing I found out, let's actually come into menu config here. So the way you configure this is you come into component config, Bluetooth, and from the Bluetooth host, you can see we can select Blue Droid or Nimble. And then once you select one of them, you get the options. So like right now, since I have Nimble selected, I have Nimble options. And you can come in, and what I was trying to figure out is with the huge size of the binary, remember, I haven't written any of my business logic code in the firmware yet. Like, this is just the scaffolding around like getting the device configured. Like, it has nothing that like runs an e-paper display and connects my backend web service and does all those. None of that is in there yet, and I'm already at like 1 meg binary size, which is huge. And so what I was doing, very common in the embedded world, is to come in and see like what essentially pound defines can I turn on and off to get rid of features to shrink the size of the binary, excuse me. And so I was looking through here, and right off the bat, when you come in here, this BLE Central role, BLE Broadcaster role, Sparky, welcome back. Just sharing some learnings from what I found out after our stream earlier with configuring all this BLE stuff. These are all enabled by default, like they're all turned on by default. And again, I knew more about Bluetooth, but definitely not an expert, definitely not a BLE expert. But in looking up, it appeared that I don't need the central role or the broadcaster role because the device is serving as a peripheral. Your phone is serving as that central / broadcaster role. But I'm going to enable those, and I'm going to exit out. And then if you do idf.py size, it's going to compile everything with all those options. It takes Not too bad. Like this laptop, Carbon X1, no, sorry, not Carbon, X1 Extreme ThinkPad, lovely. 6-core, 12 threads. It's kind of it's a workhorse. Does a good job. It'll compile everything and tell us the size of the binary. So I want to show you that really quickly. Okay, here we go. So what we get at the end of this is you can see a target binary that's around just under a meg, 966,000 bytes, which is really big. And so what I was doing was going into menu config and just like fiddling with the bits to see how I could affect the size. I meant to get the, shoot, I wonder if I can exit. Okay, it's still right here. Let's take this total image size. Let's take it all the way from here. Ugh, not Control C, Control Shift C. This isn't a Mac. Control Shift C. Okay, let's just create a new file over here. Dump that in here. Let's go back into menu config. And so I was looking through this. I figured, oh, let's turn some of this stuff off. So I came into here and said, let's turn off the central role and the broadcaster role. And we'll exit. And let's do size again. While size is happening, so I'm not wasting time, let's talk about the way my current partitions are set up. So right now I have it set up to factory OTA1, OTA2, each of those being 1 meg in size, which takes up 3 megs of our 4 meg flash, onboard flash. And then the rest of that is, you know, things like the bootloader, NVS partitions, and other things that fill that up. And as I was looking through the bootloader documentation, what I started to ask, and this is actually very similar to what mine looks like. It's got a factory of 1 meg, and then I have an OTA 0 of 1 meg and an OTA 1 of 1 meg. And so what I started thinking was, why do I have 3 partitions that have code onto them? And what is the factory partition? Like, you hear about factory reset. And so I started doing some research on that. And what I found was the user can write a basic working firmware and load it into the factory app partition. This is, I mean, you hear about it all the time, like factory reset. This is we know this. Regardless of anything that the user does, if we go back to this state, everything should work, and then we can update from that. It says, next, update the firmware via OTA. The updated firmware will be loaded into an OTA app partition slot, and the OTA data partition is updated to boot from this partition. There was a specific sentence in here I wanted to point out. Oh, come on, where is it? It essentially said, I'll have to find it. It was in here. It essentially said, like, nothing can ever overwrite the factory partition except for, you know, plugging it in and flashing it directly. Like, you can't, from within an OTA app running partition, say, oh, I want to put a new factory app in there. That's it. Like, the factory is the factory. And it talks about booting from how you would trigger a factory reset, which is it requires an IO pin, like it in the settings. And I'll show you those in a second. Let's go back and look at our size. Okay, so by turning off those two things, you can see I went from 966 to 961. So I saved about 5K. We'll come back to this. Let's finish our factory reset. So if I come to partition tables, it was in here. And I look at, like, what are the different things that you can fill it up with? And it says, right, subtype. When the type is app, the subtype field can be specified as factory, OTA 0 through OTA 15, or test. And there it says, factory is the default app partition. The bootloader will execute the factory app unless there it sees a partition of type data OTA, in which case it reads this partition to determine which OTA image to boot. And I won't go through that right now, but basically there's an OTA data partition that says load OTA app 0 or 1 or 0 or 14. Depending on how big your app is, you could have a whole string of apps, OTA 0, 1, 2, 3, all the way up through 15 that you could potentially roll back to. But right here, it says OTA never updates the factory partition. And so as I was reading that and then reading through the factory reset, you have to have an IO pin, but like this is my product, my new product sitting inside of a case like this. There's no button as of right now. And so there's really no way for me to trigger a factory reset on the device as it exists now. Now I could put a button on here and enable it through somehow in the case, like on the back of the case or something, have a factory reset. That would require us to modify the firmware again, and I'm not sure I'm interested in doing that. But that's something that I need to think about is, do I really want to have a factory reset option, or is just the OTA 1 and 2, because again, you have 2, and you can switch between them. So like if you have one that's working, like let's just say OTA 0 is your known good, and then you update, there's a way to do a check, and if the check fails, it can revert back. And so you can always, if you're careful, and that's the trick, if you're careful, you can always maintain a good state between those 2 buckets. The factory is, I did something and I screwed up both, or, in my case, both, but all of my OTA partitions, and I need a way to get back to the known good firmware. However, like I said, currently our hardware does not support that, and so the existence of the factory partition is superfluous. Like, we don't need that. And so that's a whole mega flash we can reclaim, because it says if you want to conserve flash usage in an OTA project, which we do, you can remove the factory partition and use OTA 0 instead. So we would just have an OTA 0 and an OTA 1, and since we've reclaimed a meg of flash, we can make both of them 1.5 megs, which makes, fitting these huge BLE apps into the existing flash more feasible. We still want to conserve as much as possible, but so that's what I learned after the stream earlier today, is we could, at this point in the state of the hardware, we could ditch the factory partition and just go with 2 1.5 meg OTAs. Now, do I want a factory reset? It's kind of like if you can have it, you want it. But in the case of this, there is no factory reset. There's no, like, say, the pucks that I've sent out and have customers using right now can't factory reset. So I don't know that this is a necessary addition. Again, I do expose the USB port right there. You can see it, good angle. And I will on the other device as well, which means at a worst case scenario, I can have an app that over USB flashes it, in which case that is the factory reset. Like, there's no button to factory reset, but there's a process to factory reset. Thanks for letting me talk through it. We're going to ditch the factory partition. We're going to have 1.5 meg to OTA partitions. That's the decision for now. Okay, now the other thing I wanted to show you while we're here and learning is, so we cut down on the size of the flash. Something that I was expecting was with all of these compiler flags, which is all that really is happening here when you're in menu config. Again, when I was trying to see how much I could trim down the BLE stuff, I was just coming into Nimble options and I figured, you know what, let me just uncheck everything and then it should fail to build if it needs something. For example, if I uncheck the BLE peripheral role like that, and I say don't compile it in, I would expect at link time for the linker to say, hey, some things that I need for being a peripheral haven't been compiled, and so linker error, or even compile time error, to say I can't build. That is not the case. So I have unchecked peripheral role, and we'll go ahead and exit. And what you will see is if I hit size, it's going to compile just fine. That size is going to be a little bit smaller. And then when I run this and I go into my provisioning app to provision the Wi-Fi, it just gets to a point in the app where it starts to try and do BLE things, and I get an error output here on screen that says like, sorry, I don't have the things I need to be BLE right now, which I think is kind of sucks. Like I would have expected that to be a compile or a linking check, and it's definitely not. I haven't dug into the code. I don't really care because the code I'm not going to change the Espressif Nimble BLE code. But yeah, okay. See, like here, we went down from 61 to 41. We just lost 20K, which is huge. And you're thinking, oh, cool, I don't need that. But then you find out that you need it when you're actually running, which I think is weird. Let me just show what it looks like really quick. You might find that useful. Plug that in. Let's do flash and monitor. All right, it's going to go through flashing all of that. So for now, and again, we're totally different platforms, but right now the full puck code, which also has a TCP/IP stack running on it for Wi-Fi, it's doing all those things, running the e-paper display, talking to my backend services and stuff. I believe checks in at around 100 and probably like 120K maybe, something like that. It's not a ton. It's not huge. And so I figure if I've got 1.5 meg in an OTA partition, and I'm only at around a meg with all the BLE stuff, that gives me 500K. That should be more than enough for me to fit all my app stuff in. So I think we should be okay there. Yeah, okay, right here. See this app provisioning started, and then it just says like Protocom Nimble error setting advertisement data. And that's because I don't have the peripheral stuff turned on. And so again, that's something I would expect the build system to catch at compile or link time, and it doesn't. So just something to be aware of, like if you're trying to trim down. Now in this case, it's not too bad. Like it's clearly broken at this point, but the reason it concerns me, I'm gonna unplug this. The reason it concerns me is without knowing, and you should always know exactly what you're doing, but let's be honest, we don't always. If you come into here and you're doing options and it's like, I don't know, for example, security manager legacy pairing, security manager secure connections. Like, I need to really understand what security manager legacy pairing means, because if I turn it off, everything's going to compile and link, but then I may find that like in some, like, is that a client thing? Is that a device thing? Like, am I going to find that some, line of phones doesn't work because I have that unchecked? Like lots of testing and understand. It's important to understand what all these do, but I mean, there's just so many across the entire project. There's going to be hundreds of settings that get into the hundreds of thousands of combinations of how they could interact with each other. And so, I guess that's why we get paid big bucks to figure this stuff out. But so anyway, we need, in my testing, I found we need peripheral role enabled. We can leave central and broadcaster turned off, and observer role. To be honest, I haven't checked with removing observer, but from what I've read, again, I'm not an expert on BLE. From what I've read, those are both required when the device is acting in the way that it is for our provisioning. And so, okay. So those are the things I wanted to share and show. And this is another one, for example, that I was playing with. Override TinyCrypt with embed TLS. Embed TLS has to be on there for our other Wi-Fi, for like the Wi-Fi stack that Espressif uses. And it's checked by default. I unchecked it. It actually shrinks the size of the final binary, which, I mean, I'm kind of torn. Like, I'll take any space I can get. But I was, like I said, I don't know what I could be breaking by doing that. The provisioning seemed to work okay in my, test of one device. And so settings like that, like I'm not sure what I'm I'm breaking or not breaking. So host flow control on disconnect. What happens if I uncheck that? No idea. So anyway, those are the two main things I wanted to cover. Like, we got the BLE stuff. Oh, the other thing that I want to start looking at is, let me find it. Okay, I'm going to bring this over. Let me get out of here first. Save configuration. No, I don't know what changes I made. Oh, I turned the thing back on. I did want to save that. Whatever, I'll come back to that later. Okay, let me drag this over. I think that's the same code. It is the same code. We don't need to look at the MVS flash. So from the earlier stream in the main, what we did was we came into @main.c here and started, we copied this and then we, what am I looking at? Provisioning? I don't feel like, do I have all this QR version in our code? Oh man, getting late for me, I think maybe. Do I have all that? No. Is this the code I copied from earlier? What on earth? Wi-Fi. Let's come back to provisioning. Wi-Fi provisioning manager. And I came into main. What is all, like, I don't know why, how did I miss those? Wi-Fi connected event? I've got my Wi-Fi connected event and event group handle Wi-Fi event group. But then I don't have any of this. Huh. Interesting. I think the rest of this, though, is the same. Yeah, see, I don't have this Wi-Fi prov print QR. What am I? Am I in like a different branch? What is going on here? I am. I'm not on the main. I'm on like some random. And the question is how I got there. I'm gonna open master in another. Yeah, here we go. This is the code I have, but maybe not, because it also has. Huh. Wi-Fi print, prov print QR. Is that, do I seriously? Obviously it wouldn't build if I did. Yeah, QR. Where did I get the code I was looking at? I mean, I can tell you where I got it. Let's figure this out really quick, because now I'm curious. I was in provisioning, unified provisioning. And then I came down here and an application can be found as an example under provisioning. This is also a custom branch. It's not on like a master. And then this would have been the code. Include QR code.h. I got rid of, you know what I might have done? I got rid of this for sure. I might have accidentally gotten rid of this include QR code.h. But I believe, yeah, this looks like the code I took. No, Wi-Fi prov. Again, like what code did I copy earlier, people? Well, I'm obviously going to want the latest. Man, this has totally derailed me now. Okay. The point I was trying to make, I'll revisit this because obviously I want more code than I have, is I came through and everywhere where it said soft AP, I deleted. But I believe, and this is what I want to test, I believe we can have them both enabled. And because soft AP is just through the Wi-Fi anyway, I don't think it increases the footprint very much. And so what I might want to do, if it's possible, is have both BLE and soft AP enabled. There's actually apps, at least in the Google Play Store, there's apps for both to walk you through smart config setup versus BLE. And so if the footprint's not a lot bigger, I'll do that for sure, because then I cover all my bases. Like for somebody that maybe doesn't have a BLE device, because if you're doing BLE provisioning, you're kind of hanging your code on that, like all your eggs in one basket. If they don't have a BLE device, which again, every cell phone that exists, for the last 5 years has BLE. And so that's not a huge concern. But again, if it's a small footprint price to pay, why not? Like, why not have both of them just in case? And then I can direct customers one way or the other. Man, this is bothering me that we've got this. What does the print QR code even do? Print. Weird. QR code. Scan this QR code. Oh, if QR code is not copy paste the URL in a browser, QR code base URL, which is up here, which is this jumpstart. Like, what does this even take us to? Let me guess, QR code. Yeah. It uses, yeah, I was thinking the same thing, Sparky, but it looks like it's just using this fixed one. Like, I don't see any customization on it. Print QR, because it's saying if QR code is not visible, copy and paste the below URL, and the URL is, oh wait, no, you're right. URL data equals that, which is the payload, which is, yeah, okay, some other things. Yeah, so it is it's using that base QR, and so you'd have to point to that. But okay, interesting. I still am really confused about how I did not get that code earlier when I was going through it. So the one thing let's look for this really quick. So like here, and the reason I think I can do both is because it says like if def config example provisioning transport BLE include this, and there's not an else. It's just like if def the soft AP include that as well. So I don't think anywhere in here. Yeah, same thing. Well, yeah, but right here you have to set the scheme to one or the other. Yeah. Wi-Fi provisioning manager config. Let's just look at that really quick. Manager config. This will answer our question for sure. Why don't I just search for it? Config type. Provisioning scheme to use. Following schemes are already available. We can choose BLE. Or, yeah, see, like we can't choose. So this one would be interesting to try too. Like, what does that look like? Provisioning scheme console. Let's try it real quick. I wonder if we can just swap it out. If this works, cool. If not, I'm gonna call it. I think I'm getting tired. I'll pick all this up tomorrow. Dot scheme. Oh wait, it does this in multiple places. Does it there? Oh, because yeah, that's right. I'm looking at this code over here. Yeah, I took all this stuff out and collapsed all that code down. Yeah, Okay. So let's just try it. Scheme event handler. Do I need to change? I feel like I'm asking for trouble here. There's no way this is going to work. Event handler. I assume it should just be use none when not used. Let's do that because we won't be using it. So let's comment that out and do a dot scheme event handler equals that. I have no idea if this is gonna work. Let's see. I'm just curious what like configuring over console looks like. Yeah, I'm sure there's other changes I have to make that work. Serial port scheme, like tell me. Yeah. All right. Well, I thought it might be fun to try. To see what the console look like. All right. Well, so why isn't it? I wonder why it's not. Oh, I know why. Hold on. We're not giving up quite yet. Let's include the scheme, I don't know, console. Let's try that. Why is that giving me a hard time? Build. Eh? Oh, I thought we had gotten to it. What? What's it saying? Oh, it's just trying to program, but it built, right? Yeah, did it build? What? T. Oh yeah, flash monitor. I just did build, and so it should say good. Let's plug it in, see what happens, and then we'll call it. Oh, good. All right. Because again, if I could switch between that and console, that would maybe be feasible. What am I doing? Well, trying to hold too many buttons down at once. Okay. Sparky has a note of follow-up. The bread was delicious. Turned out amazing. Very fluffy, moist in the middle. Excellent crust. Delicious. Okay. So now it should say, I don't know. I'm assuming somewhere in this output shell here, console. I don't know that. Well, this should be able to take input. Like I'm assuming it's going to ask me for questions. Let's see how this works. And then I suppose what we could do in code is we could switch between the two. But how would we know BLE is not available? You can only choose one. I'm gonna have to really think through that. Provisioning started with service name. That. So now what? I wonder if this is where we need to use. If we come back to the example code and we come up into here, there is this. Yeah. Enabling config example prov show QR code. Okay, so I think it was probably supposed to do this. Yeah. And because I don't have, Yeah. Okay. Because I don't have all the show QR stuff that's in this example code, which how did I miss that earlier? I don't know. It should just look like this, and then we would scan that. It's going to take us to, here it is. Like, here's an example of what that, Sparky, you're right. This like custom, it's going to say QR code data version 1, this, that, blah, 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 blah. And then I guess from that point, like, I don't even, just for kicks, I'm going to just scan this example QR code and see what happens. It's not liking it. Okay. Well, let's just take their example URL. Yeah, I think you're right. Let's see. Sparky's, I think he's onto something. Huh. Yeah, okay, here you go. Please scan with your ESP provisioning app. Okay, so it creates a, this creates the, and which I have right here. So let's go through this whole process. So what I think is happening now, stand by. Let's see this to the end. Provision new device. It asks me, anyway, I'll show this here. It's like looking for a QR code. It's kind of meta to like show my head over my head. So I'm going to do that. And I'm going to, oh, and it found it. Okay. Now what's it doing? It's thinking. It's still thinking. Let's go look at our output. Oh, look at all this stuff. Provisioning service started. Oh, it says device not found. I bet I know why the device is not found. Did I ever turn that stuff back on? I used the exam. Yeah, it's time to be done. I used the, yeah, Sparky, you beat me to it by like 2 seconds. That's the demo app. Like, duh. Okay. So, cool. Serial console doesn't actually mean provisioning via the console. It means it can spit out over the console a link, a QR code and a link to take you to another QR code that the ESP provisioning app can read, and you're still going to have to use the app. You got to use the app, whether you use the serial or not. That doesn't make sense, though. If I don't say BLE, like, well, no, yeah, because that's how the app is working. It's over BLE. Okay, well, I'll figure that out. The point is, I can only do one at a time. I'm going to have to pick. It's probably going to be BLE. And I'll also somehow need to leave a way to do this over serial again if there happens to be any sort of problem with BLE. And I think we've solved our partition size issue by getting rid of the factory partition. So looked like it had different. Yeah, I think Sparky, I'm gonna play with it some more because something's not adding up, and I think I'm just getting tired and my brain's mush, and it's probably difficult to watch me like stumble through this. But I think you're right. So what I'll do is I'll get this other code base that I found that is different than the code base I found earlier. Yeah, you're right in the, let's look at the thing like you're pointing out. Transport BLE. Yeah, so we'd want transport console. You're right. Yeah. So I'll play with that a little bit more because that would be cool. But I don't know how I'd have console over. Yeah, I'll have to mess with that. but I'm very curious now. And so I think we're in a good spot. I think we're okay flash space wise. We got to get this rolling. I'm actually very impressed, just to kind of wrap all this up and tie a bow on it. I'm really impressed with the out-of-box stuff that's provided for you from Espresso to be able to get this stuff up and going. Now, I wouldn't just take this code wholesale as they've given it to me and call it production. I would go through every single line of this to make sure I understand what's happening, what error codes could happen, and how I could recover. I mentioned earlier that there is quite a bit of ESP error check stuff that I would probably change a little bit and check error codes and maybe handle more gracefully. But yeah, I think we're to a point where we should be able to fairly soon, from a base firmware point of view, have a way to provision our device. I did find out also that from early searching and research on this, there is not a great way. Like if I type in the wrong Wi-Fi password, it sends it down to the device. I do get an error in the app that says like there was a problem provisioning because it couldn't connect to my Wi-Fi. But at that point, it is considered provisioned, which sucks because it'll just take, when it gets to the password for your Wi-Fi, you just type 1234. It'll be like, sure, 1234. And then at that point, the ESP32, the provisioning manager component says, am I provisioned? Let me check. Yep, I got a password, 1234. I'm provisioned. And even the app says, if it didn't work, like factory reset your device and try again. Well, that's not an option. Like that's dumb. The way I do it currently on the pucks is once I get the credentials, I try to connect to the Wi-Fi. And if that succeeds, I go to the next step, which is I try to ping an IP address. I think it's like the Google DNS server, which should have like 6 nines of uptime and be a pretty reliable indication that you can connect to the internet. And then if that succeeds, I move forward into my firmware. If any of those fail, like don't connect to the Wi-Fi access point, or I can't ping the internet, I wipe the credentials and assume, because the particle stuff had the same issue, it'll just take whatever credentials you give it and then be like, I can't connect to the internet. I can, after those tests, I can say just wipe whatever Wi-Fi password we stored and try again, so it puts the device back in a like ready to be configured state. So we'll do something similar with this to create a good user experience. So that's going to do it. Sparky, really appreciate you hopping in and being patient and nudging me along as my brain has turned to mush. I was up at 4 a.m. today, so it's been a long day. But thanks for joining. Again, hope some of this stuff is helpful to people that are learning and kind of watching me stumble through it, so you don't have to, is the idea of all this. So thanks so much for watching. Hope everybody has an amazing rest of their evening, and we'll see you next time.